Yeah. Hello friends, this is Gangadhar and this is a easy question asked in JEE Advanced 2019 paper 1 in the section of more than one answer type question. See, this is the question and we need to choose the correct option among these. The question is given like this: alpha and beta are the roots of x square minus x minus 1 is equals to 0, and an is defined like this, bn is given like this, and we need to check whether these options are correct or not. See, you need to check first. An is alpha power n minus beta power n by alpha minus beta. So what is an plus 1? An plus 1 is alpha power n plus 1 minus beta power n plus 1 by alpha minus beta, and an minus 1 is alpha power n minus 1 minus beta power n minus 1 by alpha minus beta. See, my first task is to check whether it is true or false. I need to check this one. To check this, I will start with this expression. See, usually there are different ways to prove it. Okay. One thing is considering this an plus 1 plus an minus 1 and on simplification arriving to bn. Okay. Now what I am going to do is to check whether it is true or wrong. See, I will consider this one. What it is, since bn is alpha power n plus beta power n, if you replace here, what I have, alpha power n plus beta power n, bn is equals to what is an plus 1. An plus 1 is alpha power n plus 1 plus beta power n plus 1 by alpha minus beta plus what is an minus 1, which is alpha power n minus 1. See, here you have minus, so this is also minus, and this is minus beta power n minus 1 divided by alpha minus beta. If it is true, then option A is our answer. Okay. See, to check whether it is true or wrong, just do cross multiplication. If you do cross multiplication, alpha power n plus beta power n into alpha minus beta is equals to what I have here, alpha power n plus 1 minus beta power n plus 1 plus alpha power n minus 1 minus beta power n minus 1. That is my right hand side. Now, if you simplify this left hand side, alpha power n into alpha is alpha power n plus 1, alpha minus alpha power n into beta plus beta power n into alpha minus beta power n plus 1. Okay, and I have the terms in the right hand side. See, if you check this alpha power n plus 1, alpha power n plus 1 minus beta power n plus 1 will get cancelled on both sides. Now, in the left hand side, I am going to pick out alpha into beta as a common term. If you pick out alpha into beta, I have here beta power n minus 1, and from here I have minus alpha power n minus 1. And after getting these two cancelled out, I have these two terms in the right hand side, alpha power n minus 1 minus beta power n minus 1. And it is clear that these two are get cancelled with minus 1. So alpha into beta is equals to minus 1. I have at the end. Since alpha and beta are the roots of this expression, clearly alpha into beta is minus 1. So since alpha into beta minus 1 is a true analysis, true statement, this is also true. Since this is true, our first thing, bn is equals to alpha power n plus beta power n is true. So option A is one of the correct option for this question. Okay, see, since I have options here, this is the best way to analyze it, whether it is true or wrong. Okay, if we don't have any option here, then there is no chance to check like this. At that time, we will start with the right hand side and we will try to simplify to arrive something in terms of alpha and beta. But we have here, so this is the direct and simple way of analyzing whether option A is true or wrong. Okay, there is the first option. Now, to check the second option, whether it is true or wrong, or third option. See, this is bn by 10 power n, this is an by 10 power n, and sigma n running from 1 to infinity. See, first thing what I am going to do is, I will calculate sigma n running from 1 to infinity, alpha power n by 10 power n. See, this is alpha power n by 10 power n. We will write it as sigma n running from 1 to infinity, alpha by 10 to the power n. Since it is alpha by 10 to the power n, running from 1 to infinity, so infinite terms of GP, if you use this, for the infinite terms of GP, the first term is what? N is equals to 1. So alpha by 10. So first term divided by 1 minus, the common ratio is again here alpha minus 10. And on simplification you have here it is alpha by 10 minus alpha. See what it is? Sigma n running from 1 to infinity alpha power n by 10 power n is equals to alpha by 10 minus alpha. So this is alpha by 10 minus alpha. So similarly I do it for beta also. If I do it for beta, then sigma n running from beta power n by 10 power n is beta by 10 minus beta I have. Now to check whether the second statement is true or wrong, what I need to do? I have to check like this. Sigma n running from 1 to infinity. This Bn is nothing but what? See, already we derived in the option A, it has alpha power n plus beta power n. So which is divided by 10 power n. So as sigma running, we have here it is alpha by 10 power n plus beta by 10 power n. So see, the sigma is there for both the terms also. And if you apply sigma for alpha by 10 to the power n, we have it as alpha by 10 minus alpha plus, and if you apply for the second one, this is beta by 10 minus beta. Now, if you do simplification of taking LCM, we have the 10 alpha minus alpha beta, 10 beta minus alpha beta. So we have the 10 times of alpha plus beta minus 2 alpha beta divided by, so what we have here, 10 minus alpha into 10 minus beta, otherwise 100 minus 10 times of alpha plus beta plus alpha into beta. Since alpha and beta are the roots of this expression, I have that alpha plus beta as 1, whereas alpha into beta as minus 1. Use this here. If you use these things here, we have that 10 plus 2, since it is 1 and it is minus 1, divided by 100 minus 10 into 1 minus 1. See, the numerator is 12, whereas the denominator is 89, and we have here 12 by 89, but it is given as 8 by 89. So this is the wrong statement. Okay. To check whether option C is right or wrong, again we go with the same procedure. What is A in here? Alpha power n minus beta power n, and I have minus here, and I have minus here. Then 10 alpha minus alpha beta minus 10 beta plus alpha beta. So how can I check? See. See, an is what actually, sorry to say, an is actually what? Alpha power n minus beta power n by alpha minus beta. Okay, see, so we have alpha minus beta in its denominator also, and this total expression divided by alpha minus beta we have. Okay, so this total expression divided by 1 by alpha minus beta we have here. So we need to simplify it. So to simplify it, what I have? 10 alpha minus alpha beta, 10 beta plus alpha beta. So alpha beta will get cancelled. So finally we have 10 times of alpha minus beta. So this 10 times of alpha minus beta and the denominator is same. Before that we have 1 by alpha minus beta. These two will get cancelled. Then directly the denominator is same, but the numerator is as it is like 10. So your answer is 10 by 89. So this is correct. So option C is also one of the correct option. See, option A is somewhat logical, whereas option B and option C are direct checking using infinite series of GP, right? Then coming to option D. So to check option D also, okay, I have a logic here. See, if you observe option D, what is given? A1 plus and so on plus an is equals to an plus 2 minus 1. See, alpha and beta are the roots of this expression. For what is the expression? X square minus x minus 1 is equals to 0. Since alpha is a root for this one, what I have? Alpha square minus alpha minus 1 is equals to 0. See, now we do one thing. Multiply everything with the alpha power n. Then it becomes like alpha power n plus 2 minus alpha power n plus 1 minus alpha power n is equals to 0. And similarly, if you do, we again have beta power n plus 2 minus beta power n plus 1 minus beta power n is equals to 0. Right? And if you do subtraction, what we have? See, if you do subtraction, what I have for these two terms? See, if I do subtraction for this, alpha power n plus 2 minus of beta power n plus 2. And again here, by common minus alpha power n plus 1 minus beta power n plus 1. Again for these two terms, if you common out alpha power n, no, if you common out minus, we have that alpha power n minus beta power n is equals to 0. If you divide everything with alpha minus beta, this is nothing but a n plus 2. And if you divide it with alpha minus beta, we have that a n plus 1. And if you divide it with alpha power n alpha minus beta, that is nothing but a n. See, as mentioned here, I used the terms like a n plus 2, a n plus 1 and a n. This is equals to 0. Then finally what I have? I have in my hands that a n plus 2 is equals to a n plus 1 plus a n. A relation between the consecutive terms like a n plus 1 and a n plus 2. Okay, see what I did here. See, I replaced alpha in the equation and I multiplied with alpha for n. Similarly, I wrote the statement for beta, and on subtraction I have this one. Since if you divide everything with alpha minus beta, this is a n plus 2, this is a n plus 1, and that is a n. So finally what I have in my hands that a n plus 2 is equals to a n plus 1 plus a n. This is true for any values of n. See, now what I do is, here I have that a n plus 2 is equals to a n plus 1 plus a n. Is it clear? See, if we apply the similar statement for a n plus 1, then it will become like a n plus a n minus 1. And if you apply the similar statement for the next thing, that is a n, I have here a n minus 1 plus a n minus 2. Like this, if you apply, I have that a3 is equals to a2 plus a1 and a2 is equals to a1 plus a0. And if you add all these terms, okay, this is the left hand side and sum of all these values is the right hand side, and if you compare these two and these two will get cancelled. And in the left hand side I left with only a n plus 2, whereas coming to the right hand side we have that a n 2a1. So that is a n plus and so on plus a1 plus additional terms like a1 plus a naught. See, in the option D, I need to calculate this summation. So to calculate this summation, I need to replace a1 and a naught. What is a1? By replacing 1 in the place of n. So if you replace 1 in the place of n, this is alpha minus beta by alpha minus beta. So a1 value is 1. So this is 1 plus a0. Replace n with 0. n with 0. 1 minus 1 is 0. So a0 is 0. This is 0. So clearly this summation is nothing but a n plus 2 minus 1, and this is also a correct option for the given question. So finally this is a question asked in Advanced 2019 of paper 1. Okay, so for this question your options are A, C, D. Okay, the problem is logical and little bit lengthy. Okay, but actually we have sufficient time in the advanced examination, so it is very easy for the students of average students as well as above average students and then everybody to solve this question. So if very few students, if they are below average, then they will need more time and they will unnecessarily waste some time at this type of questions. Okay, so this is a question from Advanced 2019. Thank you.